structure that we need to consider is records. Now, records are completely different to what we've been talking about so far because a record is not primitive in its nature, in the sense that we can say integers, floats, booleans, etc. All of the different data types are, if you like, a primitive data type because those are the ones that we traditionally use. Whereas a record is really a database term. And you can think about someone having a record with a hospital, a record with your, so you can have your medical records, you can have a criminal record, you can have a student record. So a record basically stores multiple bits of data. Okay, so if you use this example here of a patient's record, so a record, if you look along that's another key thing to learn here. If we go down the fields of a database table, those are fields. Yeah, these are the columns are known as fields. Yeah, and that would identify one unique piece of information about the record. So, for example, patient ID would only just be, if you want all of the patient IDs, you're going down the field. Yeah, so you're going down the column. Yeah, everybody's date of birth, again, you're going down the column, etc., etc. Now, if you go along the row, you're getting one person's information for all of the different fields. So this person's record here, patient 178, their name is David, this is their date of birth, they were born, they are a male, phone number is that. So you can see the different bits of information all get stored on the one particular person's record. Now, what's interesting to note here is, even with this example, is that we have different data types being used for the same one person's information that we're storing. For example, patient ID 178 will be an integer data type, possibly. Name will be a string. DOB will be a date and time data type. Gender, in this case, there's only two possibilities in this case, so that could potentially be Boolean, although if it's been written out, then it will be a string. The phone number, because it's got no trailing zeros, this could be an integer and it's got no spaces, but again, normally a phone number will probably put that down as a string because it could have a space in it. Then the doctor's ID, again integer, then the doctor himself, again a string, and then in the room instance here, again a string. So the key thing is you've got different data types being stored on the one identifier. Okay, so a record has multiple different data types. Now, other things to note about a record. Right, so when we want to set up a record, we would use the keyword type. Yeah, this is like if you're writing it as a pseudocode. Then the word record to indicate that this is what we have. And then here we're creating a record for a type person. And when we create the record, we need to say to it what the different fields that we want to store. Yeah, so going down the columns, as I said previously, what are those different fields and what it's going to be the data type for that field. Now, with a record, we can have different data types that we haven't necessarily spoken about. For example, we've got varchar, which is indicating that it's going to be a character of a variable length. Yeah, so basically saying it's going to be a string, and that string can be of any length up to 10. Okay, so that's what this is basically saying. We're declaring a field called name. It's going to be of data type string, and it can have up to 10 characters within it. Yeah, so hopefully that makes sense. I'll say that again. We're creating a field, yeah, as in going down the column, called name. It's going to be of type string, so that of course someone's name will be a string, and then it can hold, in this instance, up to 10 characters for that name. So if you think about the name Alice, that will be perfectly fine. If we think about the name Fred, that would also be perfectly fine. But if we think about the name Balakrishna, yeah, that will probably go beyond 10 characters, so then it would not be fine in this instance. Okay, so then let's move on. Then we've got the next thing that we're declaring here is the variable called pin. Yeah, so field pin. And what we're saying here is, again, it's going to be a string and it's going to be a character up to 4 characters. Yeah, so it's going to be up to 4 characters for the pin. And then we've got a last thing that we're declaring here, which is balance. And balance, again, the data type for that is float. Right, with the exception of pin, you would notice that it's not a rule, but it helps to understand when you're reading it, that the field names are in title case. That means we've written it not all in capitals, as we have done with the data type. Okay, so we notice there that balance is capital B and everything else is lowercase, name is capital N, everything else is lowercase. Pin is just for simplicity's sake was written all in capitals. Right, anyways, let's then go through and do a little bit more of a discussion about it. So we said we start with the word keyword type, then we set up our structure, yeah, and the name of this particular data that we're declaring, or record rather, is person, and we're then supplying it with different fields. And then we're saying here for string fields, we specify the field length. Okay, so we've just said here the length, which is what that's suggesting. And varchar is a variable length field up to a number specified. So I said here you can store up to 10. And of course we notice here that char is a fixed string length. Okay, so that means it doesn't go beyond what we've specified. So this has to be 4 characters for the pin. It can't be less than 4 because it's not a variable character, and it can't be more than 4. Okay, so hopefully that was understandable. If you didn't understand that, pause it here, go back, and hopefully play it back to yourself. Now, if you did understand it, I'm just then going to go through the next slide, which is going to test your not understanding of that slightly. So we've got a small activity here. So we've got here, we've got the same definition for the record that we had on the previous screen. And the question is asking which one of these records are invalid for the type and why. Okay, so what we want to do is identify which one is perfectly valid and which ones are invalid. So again, I would suggest pause this here, go through it yourself, and try and ascertain which one is valid and which one is invalid. Okay, I will go through the answers with you in 1 minute or in a few seconds. Right, so let's run through the answer together. So let's go through this. So the first person record, what we're doing here actually is quite significant. We've defined it and we're saying to ourselves person, yeah, this instance of this record, we're storing the word Bob for the first bit here, which is name, which is of varchar 10. So is the name up to 10 characters? It's not up to 10 characters, but is it beyond that? No, so that's perfectly valid. Then if we look at the next thing, char, it's a char and it's up to 4 characters. Is this up to 4 characters? Yes, so that's fine. The next thing is a balance. It's supposed to be a floating point, so it's got to need to have a decimal. Again, does this have a decimal? That means this particular record is okay. Right, let me see if I can get a pen here. So we could say to ourselves, this one here is fine. Now let's look at the next one along. So again, next person's name is Nora. Nora again, 1, 2, 3, 4 characters, doesn't go up to 10, so we can say this is okay at this point. Then we look at this bit here. The chart, the pin is supposed to be up to 4 characters, and it must be 4 because it's not a varchar. So this here is making it invalid at the minute. And the last bit there has a floating point, so that means that this would have been okay, yeah, except the whole thing is invalid, okay, because this here made it invalid. All right, let's move on to the next one. So the person here, again, This is varchar 10. So let's count the number of characters here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 characters. So this can store up to varchar of 10. So then that means that this, unfortunately, is an invalid input. The pin is 4 characters, so that's fine. This is also a floating point, that would have been fine, but the whole thing is made invalid because of the name. Alright, let's go to the next one. Cecil is the name here, so let's count the number of characters. 1, 2, 3, 4, 5 characters. Again, does it go up to 10? No, that's perfectly fine. Then if we look at the next thing here, it has 1, 2, 3, 4 characters within it. Again, you might think that's fine, but what's the data type supposed to be? Well, it's supposed to be a char, not an integer. This is an integer because it doesn't have the speech marks around it. So unfortunately, this is also incorrect. All right, although this would have been correct, but the whole thing then becomes invalidated because of this particular one here. Yeah, so hopefully we understand how a record is written. We also understand how we would then initialize that record with some values. So we use the name of the particular record and then we assign some values to it. Yeah, but those values must be in keeping with the actual data types that's been defined. So that just runs through what we've just already spoken about. Right, last thing to speak about here is how we can how we can write it in terms of coding. Right, so we've got the record being defined here, we spoke about before. So here we can assign that particular person's record to a variable which would store then the different values. Okay, so we got here, if you think about this as a survey, we've got first respondent, here respondent 1, their name equals Bob. So we make type person equals to the field. Yeah, so we said type of record dot field name equals to, and then we assign it accordingly. Yeah, this part you don't need to remember for your exam. The key thing you need to know for the exam is that records can store multiple different values of different data types. And of course, we know that a list will store the same data type primarily, and also a set. If we were to be asked to compare it to a set can only store the same data type. Right, so that said, I will then stop this here and ask you a question on records after.